Okay, so today we're going to review tangent and velocity. And last time we discussed about, remember we discussed there was two ways. So it's way one, okay, which is, remember it was the limit as h approaching 0, right, of f of x plus h minus f of x and what? Over h, okay? So that was the first way that we found that we used at the beginning of this semester. And now we found a new way to do it, okay? And the new way, technically, it was way 2, okay? And it's the limit. But this time you need to have a point. So x approaching a of f of x minus f of a and x minus a, okay? Now remember there's two things here, okay? This one, okay, both of them find the slope. Remember that? Both of them find the slope. Okay? Right? Except one thing we need to understand is that this one over here, this method right there, okay, no points, right? But this one's what? Point. Okay? So there's no points and point. Okay? So that's what we discussed last time. And remember that both ways here, as you find the slope, okay, you find the slope that it represents the tangent line passing through a single point, okay, on the function given. Okay. So one thing to remember, okay, go like this, okay, this is your y, this is your x. If I have a line going something like this, okay, and there's a point there, so this point right there here, okay, if you draw a line passing to this here, like that, okay, this represent again tangent line. And if you remember, if you pass the 2 points, it's technically also called a to 2 points, like A and B, okay. This one is called technically a secant line, okay. So you have a tangent line, secant line, okay, and and then we can just recapture quickly about something to remember what we did here. Okay. Okay, let me move on and go to discuss quickly about one more thing before we move on. Okay, secant line. Okay, slope 2 points. And tangent line slope 1 point. Okay. Okay, so last time we did an example, and I'd like to solve this example today. And the example that I gave you was technically example of, let me write it down here. So it's to find the equation of the tangent line to the hyperbola y equal to 3 over x. Okay, and at x equal to 3. Okay, but I asked you to do this with 2 different ways, so we need to do it. So we'll do this problem in 2 ways. Okay. So technically we're gonna have, remember, we're gonna do it in way 1. So it's gonna be m slope and the limit as h approaching 0. Okay, as f of x plus h minus f of x over h, right? And the other way would be, or way 2, we're gonna do m as the limit of x approaching a of f of x minus f of a over x minus a. And hopefully by doing both ways we could say that hopefully doing both ways, okay, they should be have the same, okay, they should have the same answer. Okay, right. Okay, so let me go ahead and move on. Okay, so way 1. Okay, so remember we had the function y equal to 3 over x. Okay, and so let's do this here. So m limit, okay, as h approaching 0 of f of x plus h, okay, minus f of x over h. Okay, so remember to do this one here, this is technically our function right there, so we're going to have to take this right there inside the function and plug it into the function up here, right? Okay, so this has to go into the function up here. Okay, so the limit as h approaching 0 is going to be 3 over x plus h. Again, whatever you had inside the function right there, okay, has to be substituted to this x right there. Okay, okay, and so minus, this is our minus right there, minus right there, f of x. Well, remember, this is what? Also your f of x right there. So it's going to be 3 over x. Okay, that's just the top. Okay, over, and this is h right there. Okay, just recall that y is your f of x. Okay. Now, from this step to this step was just a what we call a, just to let you know, a to sub into the function. Now we have to do a little bit of algebra to solve this thing here, right? So we had to find the common denominator on the bottom here, and we can go from there. Okay, so it's going to be limit h approaching 0. So you got x plus h, and you got x right there, so I think we're going to have to multiply times x and x here, right? And this one x plus h and x plus h here, right? To have the same thing at the bottom. Okay, so to let you know, I'm going to have to multiply here, since you have the x right there, times x over x. Okay, and this one times x plus h over x plus h to make things happen. Okay, so if you do this, it's going to be 3 times x. This one's going to be 3, and we have, let's not forget the minus there, x plus h. Okay, and since they have a common denominator on the bottom, which is this x times x plus h, so we can say this. It's x and x plus h all over h. Okay, now this case right now we're going to do limit. Now we're going to do a little bit of algebra. Okay, so from here to here we took care of the fraction. Okay, and now we're going from here to here, we're going to do some algebra, okay, to simplify our work. So it's going to be, if you see on top over here, you're going to have 3x minus 3 times x and minus 3 times, so it's going to be minus 3h. So remember, it's called the distribution property. Okay, right there. And at the bottom here, we're going to have step of x, x plus h, and have an h there again. Right. Now, it's going to be limit as h approaching 0. Now, it's 3 minus 3x becomes, so the whole thing here, okay, will become this, and this cancels out, right? Okay. And so technically we left, let's see what we left off. We left with this, and this is at the bottom, right? But remember, this is over 1 here, right? So we take what we call the reciprocal. So reciprocal, so it's going